Okay, so today we're going to continue on with reciprocal graphs, and we left off with class example 3, I think. So if you guys could go there. And I'll do some of the homework as well for you. So remember, you need to be able to sketch a reciprocal graph for linear functions and quadratic functions. Shaq, will you just tap her on the hand and tell her to focus here? All right, so we're gonna, looks like page 483, thank you. Let's just, before we go into 483, let's go to page 484 and let's take a look at some of this assignment. So this is what you would have been responsible for last night's homework. And we have the steps on the board here to remind us. And let's see if we can take care of some of these graphs. All right, so again, let's just jot these steps down. So number 1 and number 2, you're looking for where is the function plus or minus 1 and where is the function 0. That's the first thing you always want to do. That's your start. Okay? So we have here, we have here, and we have here. You just mark those points. The y equals 1 and the y equals negative 1, it might be wise, just like the book here does, is just sketch like a faint line in there so you can see where it crosses. And you can even do that for the part B there as well. Where does it hit positive 1, where does it hit 0, and where does it hit negative 1? Okay. Now, what do we do for where the original function is 0? What do we do for this one? We sketch a vertical line for the vertical asymptote. Okay. So it's done there. Why do we put that in? That's where the original function is 0. So at that x value, you're going to have some weird behavior. It's really weird. It just like shoots off to infinity. Okay? Okay, so let's do this. We have all the information that we need. Follow my pointer. Start at the invariant point. Okay. What's the original function doing? Watch my pointer. Decreasing towards 0. So on this same interval from 0 to 1, if we go this way and decrease towards 0, what's the opposite of that? Instead of decreasing towards 0, we boom. And you just sketch a curve that is approaching that vertical line. And it doesn't touch it. It gets infinitely close, but never actually touches, like theoretically. I mean, obviously, if you're 0.000000001 away from it, I mean, you're touching it. But theoretically in math, like pure math, you're not actually touching it. Okay, follow my pointer. What happens as this original function on this interval is shooting off to a positive infinity? For this interval, we're increasing towards infinity, so our graph should decrease towards 0. And how do you know where to start? Like, what's this spot going to be here? That's value 2. That's the y value 2, 1 comma 2. So what's the reciprocal of 2? Half. So I should go here. So I should at least get through that, and then, you know, decent enough just to sketch the rest of it. And with these linear ones, linear, very easy to predict, there's going to be some symmetry. So in that quadrant, top right version, there's going to be some symmetry to the bottom left. Okay, so starting at the invariant point, as we get really, really, really big in the negative direction on this interval, this way, as we get really big in the negative direction, the reciprocal will get really small in the same sign. So we go like this. And same idea for this little region in here. Okay, as you get closer and closer to 0, the reciprocal will get closer and closer to infinity. Okay, please go ahead and do B. Make sure you got this for linear. Okay, this is what your test will look like, I promise you. Written response, you have to be able to sketch. There's no surprises here. You have to be able to sketch an absolute value, pardon me, a reciprocal graph of linear. Okay, so do B right now. Okay, so let's take a look at what this would look like when it's quadratic. So when it's quadratic, you still have the same processes where you want to find out where y is 1 and y is, or pardon me, where y is plus or minus 1 and where y is 0. This is what you want to check. So let's go and find all those spots. 1. Negative 1, does it touch? Just about. It doesn't actually touch. And then here at 0 and 0. Okay, so what do we do when it hits 0? Put in your vertical line. These vertical lines are nice because what it does is it sort of chunks the sections of your graph, and so you basically need to think about, okay, what's happening on this chunk, what's happening in this chunk, and what's happening over here in this chunk. Okay, so let's just start left to right. Okay, let's start over here. And you always begin at your invariant point, right? Start at your invariant point. So what's happening to the original graph left of that invariant point? It's getting bigger to the left. So our graph needs to get smaller to the left. And you're not allowed to cross 0. Okay? So you just do one of these. This was on the quiz, eh? You want to do a different one? Okay, well, let's just finish this one off quick then. So those pieces are easier, and it's the piece in the middle that's kind of weird. So what's up with this spot right here? What is that value? On mine, it looks like 0.9. Doesn't actually look like negative 1. So I'll put negative 0.9. What's the reciprocal of negative 0.9? It's negative 1.1. So this spot here that doesn't actually touch, it's going to get reciprocated to here. And then what's going to happen is you're going to see this. If it touches 1, then it's invariant and you keep it there. So these are the only invariant points here. Okay, you want to do a different one, right? How about this one? On the quiz? So this one here? Okay. And this one doesn't give you any help at all. So again, where is the original function plus or minus 1? And where is the original function 0? We'll start off with zeros. Those are easy to find. Okay, negative 1 and negative 3. And at those spots, we can draw in your... Okay, you got your vertical asymptotes. Excuse me. Thank you. Okay, so we've taken care of this. What about where's the function plus or minus 1? So that's kind of difficult if you don't have lines. So let's draw some of those in. Right at 1 and right at -1. Now we can mark invariant points. These are the points that are going to be on both graphs. And there's no invariant points down low. So for the top left and the top right, with my pointer out here, all this and all this, is this easy to draw? Decently, right? So just follow it. As this goes towards 0, this goes towards infinity. As this goes to infinity, this goes towards 0. And maybe it's just the middle part that's challenging for us. And on the test, you might want to be careful. Don't just do a random sketch like this, like I'm doing. Maybe you want to be more careful. How can you be more careful? Like this guy here. This value is 2. They're giving you a nice point here of 2, so you should reciprocate that for half. And you see I'm close. So my sketch should be down a bit. You guys see that? Okay. Now in the middle here, use the vertex. What's this spot here, roughly? Roughly -1/2 for the y value, right? So it's -2 comma 0.6? Sure, 0.6 negative. Okay, reciprocate -0.6. On your graphing calculators, you guys, on the graphing calculators, you're looking for a button that says x to the power -1. That's like an instant reciprocal button. 1.2? What's the reciprocal of 0.6? 1.667. So it's almost 2. So we're just going to roughly find almost 2 in the negative direction anyway. Right here. Now using my pointer, starting at the vertex, this guy to the left is decreasing towards 0. So when we go that way, we should be, instead of decreasing towards 0, we should be increasing towards infinity. And you saw, once you got the left, you got the right. Okay, let's go do class example 3a. Or 3, class example 3. Okay, so they've given us the reciprocal. And they've given us a max point of the reciprocal. And they've given us a y-intercept. So it says, given that the original should be quadratic, can you sketch it? So this spot here on the graph, the maximum point is -3, 2. So where should that be on the original? -3, 1/2, because it's just reciprocal. Reciprocal of the reciprocal, right? So we should have a spot right in here. Now on this reciprocal graph, this funny looking thing, is there any shooting to positive and negative infinity? So that means there's no, okay, so let me write that. No vertical asymptotes, that means there's no x-intercept on original. Where's the invariant points going to be? No invariant points on the bottom, so we only have to worry about this spot and this spot. And we just took the reciprocal of the vertex. What other point did they give us? So flip 1 over 5 and you get 5. So you guys see it. And then you should have some symmetry over here. Notice that the original graph in green, the quadratic graph, it never touched the x-intercept anywhere. So there's no zeros. So that means there's no vertical asymptote. Okay, so it says the maximum on the reciprocal will be the minimum on the quadratic, the original, and that point is -3 comma half. All we did was take this 2 and reciprocate it. Okay, and then it wants us to write it in the vertex form. You guys remember this from the quadratic unit? So we have y equals a x minus, what's the p-value? Remember, this is p, this is q. You guys remember this? So x minus -3 squared plus half. And then we just have to solve for a. Good. How to solve for a? Use an x, y coordinate. That's not the vertex. Let's use the y-intercept, 0, 5. So when y is 5, x is 0. So 3 squared is 9. Subtract a half from 10 over 2, so that's 9 over 2. Divide by 9, get 9 over 18. A is half. So I just quickly went through the algebra. So if you have any questions with the algebra, just let me know. You guys okay with me moving on? Okay, let's go back and review for 10 minutes absolute value equations. Okay? And then I'll let you guys work for the last half hour. Okay, on the practice test. Okay, let's go back and review. So it's like section 2 in the okay, so page 462. Just give me a question that you guys haven't done yet. Page 462. F? F? Okay. Okay, so you have absolute value equation equal to normal sort of equation, so to speak. We have to split this into sub-intervals. You remember that? Do you want to first look at it on the calculator? Okay. Okay, so remember the process for this. This is something I would jot down on a study sheet. Original greater or equal 0. What's the original function in the absolute value? 4 minus x. Where is that positive? When x is smaller or equal 4. Okay, so to do this, this is also going to be on the test. I'll just do this on the side here. To write this, do you remember what it's called? Piecewise. To write this piecewise, you'd write down the original for that thing you just solved, x less than 4, less or equal 4. And with absolute value, we take the negative of the original, where those y values are negative, not positive. So instead of x being less than or equal to 4, it would be x strictly greater than 4. Remember that? So this is the important piece that you have to do. You have to do that part. Okay? Now when we go to solve this, you can use a t-chart and break it into the two intervals. X less or equal 4 and x greater than 4. We said that for x less or equal 4, you're going to be using the original equation. So solve that. And then for x greater than 4, you said you're going to use the negative version. So solve this. Quickly just running through the algebra. Negative x plus 2x, negative 10 minus 4. You get x minus 14. I think this was on the quiz. Negative 4 plus x, negative 2x, negative 10. 3x is plus 4, negative 6x is negative 2. So then you have to take these answers and double check the sub-intervals. So for the first one, is minus 14 valid? Is minus 14 less or equal 4? Yes. So this is okay. This answer is okay. Now look at the next one. Is negative 2 greater than 4? Back up to this sub-interval. Negative 2 is not bigger than 4, so this is not okay. So we reject this, and this is the only solution here, x minus 14. Do you need me to do one more? You can, yes. So that's the alternative style. So the alternative style is just solve both of them. Solve for the original, solve for the negative, and then plug it back in and see if both work. That's also a way to do that. Okay, so I didn't teach that directly because it kind of screws you in, kind of screws you over later when you're trying to do harder ones. But that's this alternative method. Okay, so you just solve both parts, part 1, part 2, and then plug it back in. Okay, one more. You're not going to see any quadratic absolute value tomorrow. So let's just stick to linear. Okay. Before I start this, flip back to what I just wrote. Where did I begin? Original. What about the original? Where is it what? Greater equals 0. Move the 8 over. Divide by 2, you get x greater equal 4. So when you go to your t-chart, this is where it's normal. So solve it normally. And then switch it for when it's not positive. So that will be strictly less than 4. So then you're going to have to switch this. Okay, so the positive version in the equation and the negative version in the equation. So on the right-hand side, you got a 2x minus 10. Move the 2x over. By subtracting, divided 2, I got negative 5. Now over on the left-hand side, I'm going to distribute that negative. Move the x over, you got to 6x, and 8 minus 2, 6. X is 1. And then you have to analyze these two answers. So is 1 less than 4? Yes. Is negative 5 greater or equal 4? No. So reject that one. Five A? Sure. and then I'll let you guys work after this one. So original, this one's easy. Where's x minus 8 bigger than 0? Obviously has to be when it's bigger than 8, right? Or equal to 8. So x greater or equal to 8. Go to your t-chart. X greater or equal to 8. And then x strictly less than 8. So on the right you have a normal. So 3 outside of x minus 8. And on the left you have the negative. So 3 of, just looks weird. So I'm just going to put negative x minus 8 equals 2x plus 7. Okay, so it's all the same stuff, it just looks really small. You're going to use your x-ray vision to see that. But you got 2x plus 7 on the right, because none of that has absolute values on it. And then on the left, you just got your negative version and your positive version in the corresponding subintervals that they go. So let's solve the left. You got 3, you got a negative x, a positive 8. So negative 3x plus 24 equals 2x plus 7. Send the 3 to the other side, you got 5x. Send the 7 over this way, you get 17. So 17/5. Over on the right, you got 3x minus 24, 2x plus 7. Bring the x to the left, you got x equals 31. Okay, so 31 is greater or equal 8. That's good. 17/5 is 3.4. 3.4 is less than 8. So they should both be good. Cool beans? Did I do that right? All right. Any questions before I let you guys work? All right. Practice your absolute value equations. Practice your reciprocal transformations. Good luck. Please do not spend 25 minutes on your phones or talking to your neighbors. Please work on the practice test. Yes.